Hello and welcome back to EC 497, Introduction to Human-Robot Interaction. I'm Professor Carlotta A. Berry, and this is Lecture 6 on Evaluating Human-Robot Interfaces. For Week 6 lecture, our objectives are to describe the application of human factors to human-robot interface development, list several human-robot interface concepts, explain human decision-making in the context of human-robot interaction, discuss how vigilance affects human-robot interaction, describe the sensory egosphere, and explain how the sensory egosphere improves human-robot interface. So in human-robot interface development, you want to use human factors research to develop an effective and efficient and usable interface with the incorporation of the user into the design process as a context of user-centered design. So in user interface design, you want to design the interface so that it can directly affect the operator's ability and desire to complete a task that is mostly error-free, efficiently, and effectively. This design also affects the operator's ability to understand the current situation, make decisions, as well as supervise and provide high-level commands, which is called situational awareness, while keeping their mental workload or operator workload low. So the human-robot interface concepts are based upon human decision-making. Does the interface allow the user to get the information they need to make a good decision? Are they able to be vigilant about the progress towards the mission or the task or the state of the robot? Are they able to maintain their workload while also keeping situational awareness and also minimizing human error? So this means that an understanding of the human decision process should be incorporated into the HRI design. For example, giving the human a task and observing and taking notes as they complete it with the robot, and determining things such as what screens they rely on the most heavily. Is it the camera? Is it the sonar or the IR reading? How do they command the robot to move around? Are they more preferable to a joystick or to buttons on the screen, etc.? How does a human make effective and rapid decisions in a natural environment under difficult conditions? A lot of times we will design a system and set up an artificial environment first. So you want to compare how does the human make movements or commands on the robot to complete some mission and task in an artificial versus a natural environment as well. So vigilance is understanding sustained attention signals, detection, staying alert, and being able to identify targets and maintain performance over time. In other words, the longer the human uses the interface, does their performance start to deteriorate, where they become fatigued and they're not able to engage as well with the robot? Do they become bored? Are they as vigilant as determining whether the robot is, what the robot sees? Is the robot still making adequate progress towards its goal? Has it made mistakes? Has the human made mistakes or errors? Does the robot need assistance with perception of the human to step in or to provide guidance such as via points, etc.? Operator workload is a measurable quantity of the information processing demands placed on an individual by a task. So we would obviously think that high workloads are going to lead to a reduction in vigilance. And a byproduct of that is the operator may make more incorrect decisions or mistakes, like giving the robot the wrong commands or not noticing when the robot makes a mistake, as their workload is increased and their vigilance is reduced. Situational awareness is the operator's ability to properly understand the robotic or the robot team's activities in the current environment. This may be limited by the sensing capabilities of the robot, or, for example, limited view, or even the human's understanding of the robot's capabilities or the sensor capabilities, such as the range or the sensor error or the odometry error, which would all affect the human's ability to be aware of the current robot situation. Human error is obviously an action that fails to meet some explicit standard, something done by the human, such as an inappropriate or undesirable human decision or behavior that now reduces the effectiveness, safety, or system performance of the robot or the mission or the task being performed. So a sensory egosphere is actually from my dissertation, and it's an example of something that I designed in order to improve mental workload and to increase situational awareness to help with perception when a human needs to remotely control a robot. So it's integrated into the human-robot interface along with other things such as a camera view, IR data, sonar data, a map of the world, etc. And what the human would do is use this information to assist the robot. It can be rotated so it has the robot at the ego or the center. That's why it's called an egosphere. And the sensor data is around the robot, located in context where it is in the world. And it represents a robot short-term memory. It also represents a database that could be searchable for information. If it is tied to time, where it updates as the robot moves, you could do things such as use a sensory egosphere, like go back to the time when the orange cone was in front of you, or go back to a place in time when you were passing a red ball, etc. So here's an example of a sensory egosphere using camera data that is integrated into a human-robot interface along with camera images or icons as nodes on the sphere of the robot that indicate where that information was found, along with a map and sensory motor data, along with a compass, laser, sonar at the equator of the sphere. And so now, seeing that the robot is in front of a set of steps or in front of a grassy knoll, you could do something like ask the robot to move towards the trash can or to go towards the map or the post office, etc. So here are different ways of representing environment objects, such as by using camera data that is spliced in a 360-degree view of the robot, which may or may be more helpful than looking at the full camera view or a panoramic view of the robot, or once again using icons to only represent important information in the robot's environment. Other ways to display data on a sensory egosphere would be sonar and laser data, where you would now see this in the context of on the sphere around the robot. So it would indicate, for example, in those top two images, that on the top right, the robot is near a wall or some kind of obstacle. And you could also compare this to then the sonar data as shown on the robot. And this is also a way to do sensor fusion or fashion, where using redundant sensing and maybe also integrated with a camera, you can then determine not only if the robot has an obstacle or wall around it, but what exactly it's near, whether it is a ball or, if you have a color sensor, is it a red ball, is it an orange ball, is it a blue ball, etc. So then to evaluate the robot's environment, you could put it places where it's either stuck or it's in a corner or it's in a wall. And by using the sensor egosphere, the map along with the sensor data, can you now determine where the robot is, whether the robot is stuck and needs help or human intervention, or if it is actually making good progress towards a mission or a task. So here are an example of these two interfaces where you now have some information about the robot. You can see that it sees some cones in front of it. You can see the compass data. You can use the compass data with the map of the world to determine whether the robot is facing north, south, east, or west. And then you would add on an egosphere and ask the user some questions, such as on the left interface with no egosphere on the right, do you think the robot is in a corner? Is the robot in a hallway? Is the robot in an open space? Where on the map do you think the robot is currently located? Where do you think those cones are, etc.? And so in conclusion, this is the way to enhance a human-robot interface by considering mental workload, situational awareness, as well as using interface design and user-centered design in order to make the interface most effective to interact with the robot and the human. So thinking about this in the context of your final project, you're going to come up with a human-robot interaction that involves a human who may not know anything about your robot walking up to your interface and being able to either have a conversation with your robot, to jointly complete a task with your robot. And you need to be thinking from the perspective of someone who is not as familiar with your interface, not as familiar with your robot. What types of things would they like to see? What kind of things would be most helpful for them as they complete that mission or task?